So these are some practice problems from a worksheet. At this point, I don't know whether you have already been given the worksheet or you're given it in class tomorrow, but I wanted to demonstrate a few of them for you. So first of all, on number 11, we're going to have find the perimeter. So everything in black is what you would have seen on the worksheet, and everything in green is what I've added. So you would have seen that the length of this thing is 2x minus 1, and that the height of it is 3x plus 2. So what we're going to do is we're going to set up, we need to figure out what the perimeter is. So the perimeter means to add up all of the sides. So I'm going to add these two and add these two. So I've got to add 3x plus 2 plus 3x plus 2 plus 2x minus 1 plus 2x minus 1. And when we do that, all we're doing is adding polynomials, so you just combine your like terms. So 3 plus 3 plus 2 plus 2 is 10x. And then 2 plus 2 is 4, minus 1 is 3, minus 1 more is 2. 10x plus 2. This way, given any value of x, I could just plug it into this formula and quickly know the perimeter of that whole thing. So if x equals 2, 10 times 2 is 20, plus 2 is 22. So this is a reason why you would set that up. So this one wants to know for the figure out the area of the triangle. So the combination is you have a base of 2x plus 4 and a height of x plus 3. So the area formula is 1/2 base times height. All right, so I'm going to fill in, I'm going to pull over my polynomials, or in this case my binomials, to fill in for base and fill in for height. So 1/2 times 2x plus 4 times x plus 3. I'm going to go ahead and distribute the half to the 2x plus 4 because these are both even numbers which are easily divisible by 2. So when you multiply them by a half, it's not a big deal and you don't end up with a whole bunch of fractions. So after I distribute that, I end up with x plus 2 times x plus 3. And at that point, you're just going to use your distribution. So I'm going to distribute the x into both pieces, so x squared plus 3x. Then distribute the 2 into both pieces, 2x plus 6. And that equals x squared plus 5x plus 6. Right? Then they get what seems to be a little more complicated, writing an expression for the volume of the rectangular prism. So this one is just length times width times height. So volume is your base area times height, which we talked about as length times width with a rectangle. So I'm just going to plug in a length, a width, and a height into my length, width, height formula for volume. So you can only multiply them 2 at a time. I'm not trying to distribute this all the way throughout everything. So I'm going to multiply these two first, and then I'm going to take that answer and multiply it times this one. So when I distribute the x into x plus 2, I end up with x squared plus 2x, and then I'm going to bring down my 2x plus 1. Then I'm going to distribute the x squared into both pieces, so 2x cubed, and then x squared times 1 is just x squared. And then I'm going to distribute my 2x into both pieces. 2x times 2x is 4x squared. 2x plus 1 is just 2x. Combine my like terms, and there's my answer. Alright, this one looks a lot scarier than I think that it is. It says write an expression for the shaded region, but it gives you no numbers whatsoever. It's all in variable form. We've got polynomials and monomials all over the place. So just like we did all the shaded areas before when we were doing circles, you got to figure out a game plan. This is just the area of the big one minus the area of the small one, talking about the rectangle. So I take the area of the great big rectangle and subtract off the little guy. Alright, so to figure out area of the large rectangle, I multiply length times width. And then I'm going to subtract off my length times width of the small rectangle. So I'm going to multiply these together. You have to multiply before you subtract. That's just PEMDAS. Alright, so parentheses, before exponents, before multiplication and division, before addition and subtraction. So for this one, we're going to distribute the 4x into the x plus 2, so 4x squared plus 8x. I'm going to distribute the x into the 3x plus 5, so that's 3x squared plus 5x. I'm going to use subtraction, so I'm going to distribute the minus sign to both pieces, and I end up with 4x squared plus 8x minus 3x squared minus 5x. Combine my like terms, and I get x squared plus 3x. So given any value of x, I would be able to find the area of the shaded part.